APIs. I'll just nearly finish up with this on one more slide. APIs. We love APIs. So Deadline has had a Python script API for quite some time now, and as a result, it's really quite mature. And we know it works, and we know it works. It's pretty damn reliable. Why do we know this? Well, it's CPython based. We also have Python.net in there. That's completely optional. It's just embedded. But what that means is you do have availability to use any of the .net libraries if you so wish, or just use traditional CPython. We will upgrade that to 2.7, but at the time being, there's still quite a few applications out there which are still running 2.6. It's only the likes of the latest Nuke and Houdini that have now started to ship 2.7. But as I said, we will be upgrading that shortly. Eat your own dog food. What do we mean by this? Well, the Python application plugins that we use to build support for every single application that renders in Deadline, the event plugins that we write, the scripting tools, the functions, the properties, the events, the 723 class members that effectively we expose in our script API. We know they work because if they didn't, none of the Deadline applications would process, none of the events would work in Deadline. So it's quite a mature, quite a reliable, good place to look towards customizing Deadline for your own studio workflow. So that's where we're at the moment. What have we got extra? Well, we've got this RESTful API, HTTP API, that we've now exposed via Pulse. So you do need the Pulse application to be running because we've got a decentralized workflow here when it comes to the Deadline product. We do need a point of entry. We do need someone to talk to so it can give us a response. So running the Pulse application and its web service allows us to talk via this middleman to Deadline. It's much better RESTful than obviously using a SOAP with the overhead of XML conventions that perhaps might traditionally have been used. It's much more web, 2.0. With get, put, post, delete commands, it can return JSON objects and HTTP status codes, 200 for OK and 404 for not found. Over and above the RESTful API, we've also got a standalone Python API. Simply, if you go to Deadline repository, you go to the API directory, and inside of that is a folder called Deadline. We can copy the Deadline directory straight into wherever you've got Python installed, into your site packages. Indeed, you could reference that by going sys path append to a network location of your choosing and pull in our API. And with this site package in place, we can communicate with Deadline, we can query, we can submit jobs using just native Python scripts, and we can actually start looking towards querying and submitting jobs in Deadline without even having to have the Deadline client software installed on that machine. Let's just have a look at a bit of Python to see quite how this works. In the standalone Python, with the directory copied across to my site packages, we import Deadline connect as an object, and in a main function, we can say Deadline connect Deadline con. We just need 2 bits of information. We need to know the host name of Pulse that's running, and we need to know what port number it's running under. If we don't know those and Pulse isn't running, then when we execute the script, we're going to get some HTTP library errors there because it can't find Pulse. But it's Python, so we could actually encapsulate those lines where it's errored out with a try except and just return a nice friendly message saying, hey, Pulse isn't up at the moment. So let's run Pulse. I'll just run it on my OS X machine here, but I could run it on Windows. The spec on it is so low you could run it really on any machine you may have around your facility. Probably best though if you've got a lot of rent nodes to run it on a server-based OS because of the number of connection limits Windows imposes. With Pulse running, we'll just clear that error there. We can query Deadline and say, hey, how many Deadline pool, get the pool names, the group names, the job IDs, and when we query it, we can see here the pool names have been returned. These are my group names that I've got in my Deadline setup. These are the Deadline job IDs, and then these are all the plugin names that we have for Deadline. Return that information in 0.9 of a second. So querying deadline, yeah, that's great. That's useful. But how about if we actually think about submitting some jobs? Because I said we don't need to have the deadline client software installed. Well, why don't we connect to deadline? Let's reference the two job files, the job info file and the plugin info file, and then we can literally run a command which is deadline jobs, submit job files, and then reference these two file paths. These job files are nothing more than key value pairs. Traditionally, it's exactly how you would run deadline command and pass through these two temporary job files that you could write out to some temporary space. It's going to submit a V-Ray spawner job, and then the plugin info, which is optional. We'll put in the particular application, say max that we wish to use here. So we can submit this job, and it's submitted the job in the queue in 0.3 of a second. So that's useful, but hold on a sec. Why are we having to reference these files? This is Python. Why don't we actually just encapsulate that into Python dictionaries? One the job info and one the plugin info. And we could write that information and it just holds it all in memory as we're executing the Python script. And yeah, if Pulse is down, let's just put that in a try except. So it just gives us a nice clean error message. And the job that gets returned when we submit a job, well, I said that's a JSON object. So let's just print that JSON object after it's submitted. And there you go, 0.1 of a second later, after I executed it, you can see there a JSON object being returned, which effectively is the JSON job object. It's the job that's just been submitted into the queue. Take note that the name of this job here is called submitted via Python without job files, and the previous one I showed you is called submitted via Python with job files. So with and without. If we pop into the deadline monitor, we can see here that there's two jobs in the queue here, Python with and Python without job files. And we put two jobs in the queue, they can start picking up and processing, and technically didn't have to have deadline client software installed on the machine at all. Obvious ways to really take advantage of this is there's absolutely no reason why we can't start looking towards a lot of automation using our event plugin structure here. Why don't we put this in a for loop here and say, actually, I need 500 of these jobs in the queue. So let's execute that. Let's have a look at deadline monitor. Whoa, there's quite a lot of jobs being put in this queue. Notice how it's only up to 53 at the moment. Database updating in the bottom right, saying a couple of seconds, 2, 3 seconds. So we've got asynchronous non-blocking updating taking place here in the monitor as more and more jobs are being pushed into the queue from the Python script I wrote via Pulse. And I'm a user continuing to use my deadline monitor, and I'm not getting any blocking here, and I could quite happily continue to use the monitor as it refreshes this information. You see here it's got to number 500 now. So if we pop back to the Python script, you can see, yeah, 17.3 seconds. I print out a little message, 17.3 seconds, I've just submitted 500 jobs into the deadline queue. If we just have one last look at the Restful API, best way to look at this is just in a web browser. Again, the key piece of information that we need to know is the host name and the port number. And then /API /say users, we can see here that it returns a JSON object, but also returns a HTTP status code. If I just click on the dev tools in Chrome, you can see here that I return a status code. It's green 200, which 200 means OK. If Pulse was down, it would return 404 because Pulse is not found. But we can query deadline here. We can say what are the names of the groups that are in deadline. We can look at all the slaves, for example, that are in deadline. We can also look, because it's RESTful, it will be pending as it gets that information because it's busy waiting for Pulse to do something else. We can also query specific information just on one particular slave. For example, we can say slave (name is my MacBook Pro, give me all the information and data equal all the information for that particular Mac. And you can see they're returned as a JSON object, which is all the information right now that Pulse has via the web service for my particular slave. Just to finish off, speed, performance, speed, more speed. There's a number of areas where we've had quite a few silent successes where we've improved performance across the entire deadline ecosystem. In job submission speed, in faster just deadline monitor startup on your desktop, we've improved the task collection query speed 33%. The job pending scans, I showed you how it was previously running because my slave was idle, so it will do random times it will do the job pending scan. But we've also made it so that it's completely standalone and independent and can be run as a separate process, as well as also running on Pulse, as I previously said, which helps to regulate and make the pending scans even faster. When's that a big deal? Well, it's a big deal when you've got thousands and thousands of render nodes and you've got 10, 20, 50, etc., 1,000 jobs in the queue. We've made house cleaning faster. The memory footprint on it is much, much smaller. That's a really big deal if you need to delete 10,000 jobs in your queue. You don't really want the deadline monitor slowing down for your users just because you're doing some housekeeping behind the scenes. Lots of UI improvements across the board. I just showed a great example there of how I'm punching 500 jobs into the queue, and from the asynchronous non-blocking calls, Deadline Monitor is still responsive to me on my machine. We've improved the multiple job status changing, so when you shift select a very large quantity of jobs and you change them perhaps from queued to suspended or delete, we've improved the performance there, as well as job candidate filtering in the slave list, so you can quickly filter the slave lists for what slaves you wish to look at. And indeed, even just deleting job reports in the queue, we've made that faster as well.